Let's look at the three ways in which a function can contain a point or points where the derivative doesn't exist. Each of the ways below corresponds to a different reason why the tangent of the function doesn't exist at the given point. The first, and perhaps most intuitive reason why the tangent line doesn't exist, is if the function isn't defined at the point. Remember, if a function is not continuous, it cannot be differentiable. Here are the three types of discontinuities that a function could have. If there is a hole in the function, such as this open circle at the point, negative 2.5 comma 2.25, then a function is said to have a removable discontinuity at x equals negative 2.5. If the function has a vertical asymptote, it is said to have an infinite discontinuity. For example, this function has a vertical asymptote at x equals negative 1. Finally, if the values of a function to the left of a point and the values of the function to the right of a point do not meet at the point, you have a jump discontinuity. In this function, note the open circle at the point 1, 3. As x approaches 1 from the left, the value of the function approaches 3, but the function is equal to negative 3 when x is 1. Notice also that as x approaches 1 from the right, the value of the function approaches negative 3. If we look at the graph of f of x equals negative 2 times the absolute value of x plus 9, we see that the function comes to a point at 0, 9. The slope of the tangent lines to the left of x equals 0 is 2, and the slope of the tangent line to the right of 0 is negative 2. Coming from the left and the right, the tangent lines do not have the same slope, so the function has a sharp corner at the point 0, 9. The final condition where a function fails to be differentiable can be seen in f of x equals the fifth root of x minus 1. Looking at the point 1, 0, we see that the curve appears to be vertical. In fact, the tangent line is vertical when x equals 1. This means that the derivative is undefined because the slope of a vertical line is undefined. Now let's look at an example. We'll examine this graph for points where the function isn't differentiable. The most noticeable thing about the graph is its behavior when x is 3. As x approaches 3 from the left, the value of the function approaches negative infinity, and as x approaches 3 from the right, the value of the function approaches positive infinity. This means that the line x equals 3 is a vertical asymptote of the function, and we say the function has an infinite discontinuity at x equals 3. Let's look for any other regions where the derivative will be undefined. The function looks like it could have a vertical tangent here. We'll need to look closer at this region. The curve appears to be vertical when it crosses the x-axis at negative 3, 0. We'll draw a vertical line to make sure. The tangent is vertical at negative 3, 0, so the derivative will also be undefined there.